Okay, Trig, this is the second half of 1-3. Homework assignments over here if you need to pause the video and get that information. But we are on like example 5, I think. No, example 7. Example 7. We only have, I think, 4 examples left, but there's like a bunch of parts to them. So here we go. Example 7. They want you to find x and y intercepts, okay? So I don't remember if we've done this before or not. This was my algebra 1, I think, was doing x and y intercepts the other day. And so I taught him this way. I said, okay, so this is the x-axis, right? And like, let's say this is an x-intercept, and this is the point 2, 0. And this is another x-intercept, and this is 5, 0. And this is another x-intercept, and this is -3, 0. Those are all x-intercepts, and what they have in common is that the y-coordinate is 0. So if you're trying to find the x-intercepts, you plug 0 in for the y-coordinate, right? Because all of those are zeros, okay? This is the y-axis, and so let's say this is the point 0, 1. Let's say this is the point 0, 5. This is the point 0, -6. Those are all y-intercepts, and all of those have in common that the x-coordinate is 0, right? So if you're trying to find the y-intercepts, you're going to plug 0 in for x. Yeah. So they want us to find the x and y intercepts of this function right here, okay? Now, you guys, most of you, some of you, hopefully know that this guy's parent function, if we're talking about the parent, is y equals x squared, right? Like if I strip everything else away, y equals x squared is his highest power, and that is a parabola, all right? But then the -4 is going to move him down 4. So this thing is going to be a parabola down 4, and it's going to look like this, right? So when we're finding x-intercepts and y-intercepts, we can kind of maybe see, I guess, what the y-intercept is, but then we know that he's going to have 2 x-intercepts, right? Okay, so let's do the x-intercepts first. That is usually just a touch harder, just because he may have multiple x-intercepts. So x-intercept, we're going to plug 0 in for y. So 0 goes here, like your f of x is your y. So 0 equals x squared minus 4. And I'm just going to solve for x, right? So because this is not a trinomial, I have this x. I'm going to add the 4 to the other side. So 4 equals x squared. And I'm going to take the square root. But keep in mind that when we take the square root of 4, it is plus and minus 2, right? So I have 2 x-intercepts, and they are at +2 and at -2. That's where those guys go, okay? X-intercepts. Now the y-intercept, I'm going to plug 0 in for x. So y, that's what f of x is equal to 0 squared minus 4. I just plug 0 in for that guy, okay? 0 squared is 0, and 0 minus 4 is -4. And that's kind of what we figured, right? It was at -4 right here because he's moved down 4. So that's what I've got going on there, all right? Now, you will not always have 2 x-intercepts. You may only have 1, you may not have any, right? If this parabola is up here at the top, right, we won't have any. And that's kind of what we're looking for when we do the quadratic formula. We're trying to find where those x-intercepts are, right? We're trying to find where he crosses. So sometimes you won't have any x-intercepts, but one thing that you do know is that if this thing is a function, which means he passes the vertical line test, he will only have 1 y-intercept and no more than that, right? He cannot have 2 y-intercepts and pass the vertical line test, right? Like this parabola on its side is not a function. He doesn't pass the vertical line test, and he has 2 y-intercepts. If you want him to be a function, he won't pass the vertical line test, okay? Or if you want him to be a function, he can't have more than 1 y-intercept. Okay, so that's how that works, all right? Now they want us to talk about domain and range. They're going to do domain and range of a graph here, and then they're going to talk domain and range of, like, what if it's a function instead, right? Layla? What? Okay, never mind. Okay, so this is a discrete function. I don't know if we talked about discrete versus continuous before. This is a discrete function where we just have dots, okay? And the easiest thing to do there, you don't have to do this, but the easiest thing to do when you're listing domain and range is to put them as a list of ordered pairs, right? Okay, so I'm listing all those dots. I don't know this. I'm going to do this one first. That's -3, -4. This one here is at 0, 1. This one here is at -1, 3. This one here is at 2, 4. And this one is at 4, 4. Okay, now I'm listing domain and range. And I think we did this yesterday. We did the squiggly brackets, right? The domain elements are going to be your x's. So I want to go in order. So I'm going to go -3, -1, 0, 2, and 4. Those are my domain numbers, okay? Then the range is going to be these guys, okay? And you only list them once, even if they repeat. So -4 is the first one. Those are in order, 1, 3, and 4. Okay, I don't have to list the 4 twice. So that is that. And then determine the domain and range. They don't ask whether this is a function or not, but it is. Even though this 4 repeats twice, like these are on the same level, it will pass the vertical line test, right? It won't pass the horizontal line test, which is a different thing. We'll talk about that later on in the year. We do the horizontal line test for something, but the vertical line test he does pass. So that is a function, but that's the domain and range. All right, now B is a continuous function until we get to like this dot right here. But he is touching not just individual points like this one is, but like every single point. Like if you're saying, okay, -2 and -1, it's touching like every single point between -2 and -1. So we can't just list -2 and -1. Like that's not how that works, all right? So here's what I'm gonna do. I'm looking at the x coordinates, okay? So for domain is x's, right? And here it's talking about x's. So x's go left to right, okay? So what I'm looking at is, will he go to the left forever? No. Like he stops right here. Will he go to the right forever? Yes, he will. He'll cover all of those to the right. So at what x coordinate does he start? He starts at an x coordinate of -3 and he goes forever to the right because x's go left and right, okay? So x has to be greater than -3. Now he's not greater than or equal to because this is an open circle, right? Okay, so that's what we're looking at there. Ooh, x is greater than -3. Now the range is the y coordinates, okay? So y is something, right? And y coordinates go up and down. So I say to myself, does he go up forever? Yes, he does. Does he go down forever? Nope, he stops, and the lowest y coordinate that he goes is -2, all right? So y has to be above -2, so greater than -2, and because that's an open circle, he is not equal to right here. He's just greater than, okay? So that's domain and range for this guy, all right? Kind of similar thing over here. We have domain, we have range. Sorry, I'll zoom out so you can still see that one. Again, domain is the x's, and the x's go left and right. So I say to myself, does he go to the right forever? Does he go to the left forever? Does he touch every single number in between those two for x's? Yes, he will. He'll have a coordinate for every single value of x because he will go to, as he goes down, he will go out. So he will touch every single value of x in between, all right? So the domain is going to be all real numbers, okay? The range is up and down. So will he go up forever? Nope, he'll stop. He will go down forever though. So the highest point that he goes is at 4. So y has to be everything lower than 4, but it is also going to be less than or equal to, because you kind of treat it, if he touches 4 exactly, you treat it as though there's like a solid dot there. Like these are all solid dots that are being connected, right? So x is less than or equal to 4 is going to be your range. So that's what he is going to look like for domain and range, okay? All right, so that's when you have graphs. Now we're going to talk about, I think, just strictly domain, not range, right? Domain is a little bit more special than the range is, okay? So when we're talking domain, there are 2 things, like 2.5 things, okay, that I call domain errors. Domain errors, and these are the only 2 things. We'll write this down. Memorize this. Remember these 2 things, okay? There's 2 things that are domain errors, okay, like 2.5. Right? But I'll tell you what the half is, right? The one thing is, for domain, we can never, ever, ever have a negative inside of a square root. If we do, like, we end up with an imaginary number, and that's bad, right? So we have to figure out what x cannot be so that we don't ever have a negative inside of a square root, okay? The next thing that we can never do is we can never divide by 0. As long as these 2 things are not happening, we will not have any problems or domain errors, right? Okay. My calc kids, you guys know that if you're dividing by 0, that a lot of times will end up either being a va or a whole, right? Okay. And so that at a va and a whole, that's where your domain like poops out, right? Like it's not filled in for the x coordinate. Okay. So there's how that works. All right. there's like a half. I say it's like 2.5 because I don't really consider it another error. But another thing that will restrict your domain is, if you want to call this 2.5, is story problems. Okay. So if you have a story problem that involves an equation or something, whatever, that may end up restricting the domain, because let's say your story problem has to do with distance or time or length or whatever. You usually will end up that x has to be greater than 0, right? So I say that your domain is restricted to story problems, but I don't usually call that a rule, because like that's unique to story problems, right? Okay, so that's how that works. All right, write the domain of each function in interval notation. So keeping in mind these two rules, okay, A is going to be a violation of rule number 2. I cannot divide by 0 because I have it's potentially violating rule number 2 because I have a bottom, right? Like I have a denominator here, and I could potentially have 0 in the bottom, and I don't want that to happen. So what we're going to be looking at is whenever we have a bottom, we don't care what the top is. X plus 3 can be anything it wants to be, but I know that 2x minus 5 cannot be equal to 0, right? We've done this before where we've had like 1 over x minus 3, and you guys have told me before that x can't be 3, right? Okay, so you guys can do that in your head, but like, can you do this one in your head, right? Can you tell me what x can't be if it looks like that? Okay, and I'll show you a really easy way of doing that. All you do is say, okay, 2x minus 5 cannot be 0. Then I just solve this thing like this is my equal sign, right? I'm going to add the 5 over, okay? 2x cannot be 5, and then I'm going to divide by 2. So x cannot be 5 over 2 or 2.5, okay? X can be any single other number. It cannot be 2.5 because otherwise it will be in a violation of that domain error, okay? All right, let's go on and pick on B. Okay, B also has a bottom, right? Okay, B, we want to look at this bottom and we want to say, okay, x squared plus 4 cannot be equal to 0, okay? All right, some of you guys have already figured this one out. If you subtract the 4 over, x squared can't be negative 4. And if I take the square root, x can't be plus minus. The square root of 4 is 2, but the square root of a negative is an imaginary number. So what this is saying is that in this function, x cannot be this imaginary number. X cannot be an imaginary number. So that means x can actually be anything it wants to be, right? Let's look at this a little bit further. X, if this was minus 4, this would be a huge difference, right? But x can be whatever it wants to be, because no matter what, if this is like, let's say a negative 2, and I end up squaring it, it's going to be a positive number, and I'm going to add a number to it. It's never going to end up being 0, right? If I'm adding that 4 to it, okay, and squaring it. So x actually can be any real number, right? Because x can't be an imaginary number, so x can actually be anything that wants to be, okay? So that's kind of a weird thing, because he's not a difference of squares. He's actually a sum of squares, which is not a thing when you're breaking him down. He's a sum of squares. He will never end up actually coming out to be 0. There's no way that x squared plus 4 can be 0, no matter what you plug in for x, okay? All right, now let's talk about this guy. This guy is in a violation of rule number 1, which is we cannot have a negative inside of the square root, okay? Now, these ones are a little bit harder to do. Here is how you do this. Step number 1, set the inside equal to 0. Step number 2, number line. Okay, and I'll show you how to do this. Some of you guys can do this without a number line, without all those steps, totally fine. I'm going to show you this is how you do it without having to think about it too hard, okay? So we're going to set that thing equal to 0. We're going to say 2 minus t has to be equal to 0, and I'm going to solve for t, okay? So here we go. If I add t over to the other side, instead of subtracting the 2, I have 2 equals t. Perfect. I'm going to now put that's called a critical number, if you want to write that down. It's a critical number. Calculus, we will end up doing critical numbers like this chapter. We'll talk about critical numbers, okay? So 2 is my critical number, and I'm going to plug 2 in there, right? Okay, so I have to do some checks here. And I'm going to check a number that's over here. I'm going to check a number that's over here, and then I'm also going to check 2, like, individually and see what's going to happen. What's that? Okay, so if I check a number over here, let's just pick a random number that's on that side of 2. It doesn't have to be anything specific. I always try to use 0 if I can, all right? So I'm going to plug 0 in here, and 2 minus 0 is 2, and the square root of 2, can you take the square root of 2? It's not nice, but can you do it? Yes, you can, so this works out, right? Now let's pick a number over here, and let's say we'll just use the number 3, I don't know, okay? So I'm going to go back to my original function. If I plug 3 in, 2 minus 3 is negative 1. Can you take the square root of negative 1? No. So that region is not going to work. Now let's check 2 together, right? Let's check just 2. If I plug 2 in, can you plug 2 in? 2 minus 2 is 0. Can you take the square root of 0? Yeah, you actually can. The square root of 0 is 0, right? So I'm going to, it's basically like I have a solid dot on 2, and this is my solution, right? And how do I write that in interval notation? That's going from negative infinity to 2, and it looks like that. That is my solution. X's or t, I guess in this case, can be anything less than or equal to 2. Okay, that's how he works. All right, so a little bit more work involved when you're dealing with domain error number 1 than domain error number 2. Okay, all right, last one on this thing is this absolute value of 4 plus a, right? Okay, now we have to kind of think about these two rules, right? A negative inside of a square root and dividing by 0. So he does not have a square root, and he does not have a bottom. So that's kind of interesting. Like, how do I figure out what a can and can't be when he doesn't violate any of the rules? Well, let's think about the graph of an absolute value looks like, okay? Absolute value is going to end up looking like a V. The 4 is going to move him. Actually, the 4 technically moves him to the left 4. 1, 2, 3, 4. Which we'll go over that. But if we're looking at domain, left and right, will this thing go to the left forever? Will this thing go to the right forever? Sure, yeah, it will. His domain is all reals. He is not in violation of any of these rules up here, either of those rules up there. So he is going to touch everything. He's going to have all reals, kind of like this one did. Okay, no problems with that one. All right. Weird things when you're dealing with equations. All right. So there is that. That was domains of equations and how you treat them. All right, now the last one is asking us to analyze this graph. This kind of seems familiar. So my calc kids, like we did stuff like this when we talked about limits. It's kind of a similar process where we're trying to look for that stuff except no limits, right? Ooh. So they want us to go ahead and figure some things out using this graph. It says determine f of 2, okay? Well, f of 2 means like the y coordinate at 2. What is the y value when the x value is 2? What is y when x is 2? So 2 on the x-axis is here. What is the y value? 5. This is 2 comma 5. So f of 2 equals 5. There you go. Okay. This one is determine f of negative 5. So what is the y coordinate when the x coordinate is negative 5? So I'm going to go negative 5. What is the y coordinate? Okay, the y coordinate should be negative 3. Like if this was a limit question, the limit would be negative 3. But what is the actual value at negative 5? It doesn't have one because it's an open circle. So this one is undefined. Circle with a line through it. He doesn't actually have a value at negative 5. Okay. All right. Now, let's go to, yep. We'll just keep on track. Okay. This one says find all x's for which f of x, and f of x is another way of saying y, where y is 0. Okay. So tell me what the x's are when the y value is 0, right? Okay. So let me go here. The y value is up and down, right? Y being 0 is like this guy right here, right? This way. So he actually has 2 values where the y coordinate is 0. Okay, and those values of x are at negative 4 and positive 4. Okay, so let me tell you that again, right? A y coordinate of 0 has x coordinates here and here. If they said the y coordinate of 2, he has x coordinates here and here where he touches a value of 2 at, right? Okay, so our answers are for that one are going to be negative 4 and 4. Negative 4 and positive 4, okay? Same thing in the next one. Find all x's that have y coordinates of 3. Okay, so 3 is right here. Find all x's that have a y coordinate of 3. Okay, this is kind of weird. He is touching 3 all the way from here to here. And right here, he's touching 3. Okay, is that? Okay, so from here to here, this, if I write that in interval notation, is from an x-coordinate of -3 to 1. But how do I write it like that? I'm saying every point from -3 to 1. Well, every point from -3 to 1 would be like this in interval notation, right? And it's brackets because it's actually a solid dot here, right? It's a solid dot there and a solid dot there. So he's touching every single value from -3 to 1. We wouldn't just list -3, -2, -1, blah, 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 all of those things, right? Actually, yeah. I wouldn't list those values because he's touching every value in between too, right? So I have -3 to 1, and you can put union if you want to, and he's touching right here, which I don't know if you want to put, he doesn't look like he's right at 3. Let's say 2.9. I don't know. That's my y coordinate, and that's all where the x, or excuse me, that's all the x coordinates where the y coordinate is 3. Okay? Kind of messy, kind of messy. Let's go -3, 1. Oh, bracket. I'm going to say union with 2.9. Okay? All right, so that's all of that. All right, now we get into the x-intercepts. Determine the x-intercepts. X-axis is here, x-intercepts are here and here. That's another way of asking x-intercepts where the y-coordinate is 0, right? Y-coordinate is 0 you plug 0 in for y when you're trying to find the x-intercepts, right? Okay, so that's consistent that those two should end up being the same answers, right? Determine the y-intercept. This one only has one y-intercept, and it is at 3. He's intercepting the y at 3, okay? Last thing, domain and range. So domain is x's, and x's go left and right, okay? So I'm looking at this thing, and I'm saying, will he go to the left forever? No. He stops here. Will he go to the right forever if he starts at -5? Yes, he will. He will touch every single value from -5 on, but he doesn't touch -5 exactly. So x has to be greater than -5, right? Or you could write that as -5 to infinity. He will touch every single value of x from -5 to infinity, like not including -5 because it's an open circle, okay? Now we're talking range, and range is up and down, right? Okay, so going down, he will go down forever, because even though he doesn't go down forever on this side, he will touch all of the values here going down because that one goes down. So he will touch every single value going down, right? Up, he will not go up forever. The highest he goes up is at 5, right? Okay, so the y values have to be less than 5. Now, is it less than 5 or less than or equal to 5? Well, technically there is a solid dot here because it's not open, right? It's actually touching 5, so it should be less than or equal to. Or in interval notation, that is -infinity up to 5, right? That's what he looks like, okay? Good? All right, there is that. That was a lot of stuff going on, all right? But that's the end of 1-3. I think that was 1-3. 1-3. Yep, so there's your homework again. If you need to pause it, go for it. Yeah, there you go.